Hello again. So let's say you're in your chemistry class, lab, and you're trying to measure some liquid of some sort, like a certain amount that you want to pour into another solution. And you're using a graduated cylinder to do so. How would you do so? How would you read how much liquid there is in such a cylinder? Let's take a look. So we can get a bit of a closer look into how the liquid is behaving and which at the end in which we want to measure how much there is, just as right here. You see, sometimes liquids, because they are attracted to the walls of the cylinder, get a little bit of a curve like that one that is right there, right? That curve is what we call a meniscus. And to measure how much liquid there is, we need to take into account that meniscus. And how do we do so? We measure it by taking the bottom of the meniscus as the point of reference, right? Because we have a scale in this side, and we want to use the scale to figure out how much volume of this liquid we have. And the point we use to tell that is the one that is right here at the bottom. In this case, we can check and see that it's falling somewhere on the lines there. So now that we see where the bottom of the meniscus is falling, we need to figure out, well, what is the value there? How much liquid there is according to the scale. First things first, we need to look at the scale. We're in milliliters, and we have this first mark of 50, then of 40, then of 30. So we're going in increments of 10, and we need to figure out how many lines there is in between those. We can see there's 4, 5, 6, 7, 8, 9, 10 lines in between every mark. So we know that for each line since it's a change of 10, and we have 10 lines, for each line we're going to be increasing or decreasing by 1 milliliter. Okay, so now that we know that, we can tell that for each line, let's say if we start at 30 right here, the next line is going to be 31, the other one is going to be 32, and so on. So we need to figure out where is our mark that we have from our meniscus falling. As far as we know, this line right here is the mark of 35 milliliters, right? And the one that is next is the one that gives me 36 milliliters. But the meniscus is falling in between those. So we need to sort of figure out, because we know that 36 is above the meniscus. So we know that it is not going to be 36. This gives me certainty that it's 35 and a bit more. So it's going to be 35 and a bit more. So we can be sure that it is going to be 35 at least milliliters. But how do we tell what the number that comes after that, or how much more than 35 it is? So this is what we do. We check where the meniscus is falling, and we are going to eyeball how close to both of the lines it is, how close to 35 it is, and how close to 36 it is. In this case, it seems to be falling in between 35 and 36. It doesn't seem to be closer to one rather than the other. And this is a bit subjective in the sense that you need to observe it for yourself and make a call on whether it is closer to one or whether it is closer to the other one. Since I can just see that it is maybe in between both of them, I'm going to say that, okay, it is going to be 35.5 because 5 is in the middle. If it was a bit above, then I could go, okay, it's 35.6 or 0.7. If it's a little bit below, then 35.4 and so on. So depending on the mark, on where the mark falls and how close it is relative to each line, you determine the last number. Let's look at another example on how to measure the amount of liquid in a graduated cylinder. So let's say we measure again and get the meniscus up to this point now. Let's first check, just as we did before, where the bottom is. Let's check where the bottom of the meniscus lies. And it seems to be that it's very, very close to that line right there. Very, very close to that line right there, not quite there. Maybe it is there, maybe it isn't. So let's first figure out what number are we certain that this is, right? Which of these two lines, what do those represent, and closer to which one it is. So we have a mark of 40 here and a mark of 50. That means that between these two there was an increment of 10 units. So let's check how many lines we have in total. Well, we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines in between. So for each line, there is going to be a 1 milliliter increase. So that means that this is 40, this is 41, 42, and so on until we get to 44 and 45. So let's take a closer look then. So the meniscus seems to be falling underneath the 45 line. Let's assume that it is underneath the 45 line and above the 44 line. So we know then for certain that it is not touching the 45, sort of, and that it is above the 44. So we know that we're going to have at least 44 milliliters there. But we don't know, well, it is not exactly 44, so we cannot just leave it like that. So we just need to give a judgment to how much more of 44 we have there. And in this case, we see that it is pretty close to 45. So we can say, since it's pretty close to 45, we could give this maybe a 44.9. 44.9 means almost 45, right? Maybe somebody else sees this and says, well, it's not that close to 45, maybe 44.8 might be more accurate. Well, that's also fine. But we know that we're in the realm of almost 45. And even then, another person can look at this and say, hey, that's not 44. That is 45. Exactly. And these are all fine because they are pretty close to whatever this line is falling on. And we're going to come to an important point in this because, well, we know this number is for certain, this number is for certain, and this number is the one that we don't know that it is for certain. That it can vary depending on who reads it, but more importantly, we are not sure where that line falls, and this is what we are not sure of. So that's an important concept that we will see in the next video.